Welcome to the Clouds for Little Planets technical guide. After installing, you should see in your add-ons folder Clouds LP here. This comes with an example scene that we can open, and if we zoom out, we'll see a little planet with clouds, surprisingly. All the cloud configuration options, and the atmosphere too, are located in the compositor. For this example, it's in the World Environment compositor, and we'll expand that. In the compositor effects, and we'll see Clouds LP here. Here are where all our settings live. We have the effect global settings here, and then we have additional quality profiles and then the planet's profile. Most of the settings live inside of the profile. So we have planet, atmosphere, and the clouds. Now both the profile, cloud quality, and the effect itself are all resources. And they behave like any other Godot resource. So for example, if we were to look at the noise here, and we have a height control for controlling the layers of the clouds, this is a resource, and for the textures, they're usually nested resources. So in this case, whenever we see a link here, that's referencing something outside of the current local scene. If we were to left-click here, we make cloud quality unique, and we can adjust these values without impacting the pre-made one. And we can reload the pre-made one here, make sure add-ons is on to use the provided ones. And similarly, if we want to adjust the height without messing with the original that came with it, instead of left-clicking on this one, since there's two resources, we'll right-click, and you'll see it'll make both unique, and we can adjust the gradient here. And then if we want, we can reload the original. Clouds do have animations, and in this example, animations are turned on, but we're not really seeing them in the editor. One trick to get them to update is to show either view information or frame time. So if we enable that, we should start to see the clouds move. And then if we disable that, we won't see them move. Like with this example scene, the add-on comes with several templates like cloud quality and planet profiles. Let's load one up now in a new scene. So let's set up our scene. I'll add another world environment. We'll set the background to black. And under compositor, I'll create a new compositor, expand the effects array, add an element, and we can either create a fresh clouds LP, which we'll look at later, but for now, let's load up the given template. And this template has a 50-meter radius profile. So we'll zoom out, and we should see the atmosphere and the clouds. Let me go ahead and fill this scene out with an actual geometry planet. So we'll match the radius. And we'll make it a little smoother. And give it a material. And we'll go ahead and add a light, which we can attach to the compositor. This should work with all lights. We'll use a directional light here. And we'll go ahead and assign it. Before we do, though, notice the link on the template. We want to make something unique, so I'll go ahead and left-click to make this template local to the scene. That way we can reuse the template without messing with any of its existing settings. So I'll go ahead and assign the directional light. And now if we move the light around, we see it operates as expected. Let me come back over here. And I'm actually going to save this effect so that we don't have to keep nesting down through the compositor. And if I come over in the file system, double click it, you'll see we can edit it right here. It's exactly the same. And we can do the same thing for the planet profile too. So I'll click here on the Earth to make it unique, and I can go ahead and save it, so when we make changes, we can save it to that file. Before we take a look at all the various options we have, let's focus on performance first. So I'm going to zoom down to a cloud here. And we're going to mess with performance. I'm going to make this unique again, since I don't want to mess with the original profile. And you'll see that we have step size, and a scalar here. These together dictate how far we can draw clouds and what their accuracy is. So if we reduce steps, you'll see we reduce how far we can draw. We can increase the step size, but we'll get less good-looking clouds. Now, for every step taking in the sampling, we can also scale it out, so this kind of produces a level of detail and extends our range without adding extra steps, but it does generate artifacts. There's debanding to prevent these kind of artifacts, but it comes at a cost of adding noise as well. So a lot of these are finicky to balance together to get the right performance that you're looking for versus the style that you're looking for. There are included quality profiles. You'll see high, low, medium, and very high. We'll return back to high. And then the largest impact overall is how we scale down resolution to draw clouds. There's two options here, one for the editor and one for in-game. And you can see the game would run at a quarter, and we can have the editor match that so we can see what the clouds would actually look like in-game. And we can approach native resolution, or even do native resolution, but performance gets impacted. Let's take a look. So see, we're running at 63 frames a second here, going to half. We don't lose that much fidelity, but we really improve our performance. And then we can go to a quarter, which also improves it, and there's not too much degradation there. So looking at the options we have, we can enable debug output. Normally this is turned off, and it prevents the shaders and compute script from writing anything to the logs that isn't an error. If we turn this on, we'll see info. So if we were to adjust this here, we'll see what the compute is actually doing. And same thing with reloading. We'll go ahead and leave that on. Now, reload lets us force reload the shaders. So if we swap out a noise texture, we would want to force reload to recapture that texture. I'll just go ahead and do it now. It doesn't take very long, or shouldn't take very long. And then if we take a quick look at planet profile here, we see planets dictate whether or not they have clouds or atmospheres. But we also have overrides here in the effect, so that if we load in other planet profiles, we can let the effect dictate what gets drawn. We can also reset any animations that happened. And we'll skip over flat world for now. And then max distance, as long as this is set to 0, it'll render whatever it can determined by the cloud quality profile. If we put a number in here, we'll see it reduces the draw distance. So now onto the good stuff. We already saved our planet here. We can just open it over from the file system. And we'll start with atmosphere. So for now, I'll disable the clouds. Height is pretty self-explanatory. It's the distance from the radius of the planet, so sea level, that the atmosphere extends. Light absorption is a work in progress. And then density dictates how dense the atmosphere actually is. Now I'll turn the clouds back on real fast. Since they're receiving lighting from the atmospheric density does impact how dark the clouds get. So as we increase density, you'll see the clouds get darker. And if we decrease them, they get lighter and receive less color from the atmosphere that is no longer there. And then density fall off, larger values will make softer transitions into space, and smaller values will create hard edges. And overhead scatter determines how much of the sky becomes opaque. It adds an artificial scatter. So as you can see, we can't really see the grid that well from the ground. If we want to open up the sky, we can reduce this value. And if we want to hide things like stars or other planets during the daytime, we can increase this value. And then artistic visuals are under style. So we have star glow here. This is very sensitive. We can increase the star size here or decrease it. And then color direct will be our daytime colors, and color tangent will be our sunset colors, essentially. Color tangent is more additive, so this yellow will essentially be added together to produce reds. Let's mess with our daytime color. And then if we fly over to where sunset would be, you can see we have our yellow, orange, reds, and a blending between the color direct. So we could change this to a greenish blue sunset. And if we push out here, we can see how haze and sunset start and max affect the sunset. Start represents the initial value when the effect starts to take over, and max is when the effect is at its highest. So this is true for both haze and sunset. For haze, this is a multiplier to the height of the atmosphere. So haze start is saying at a distance of twice the atmospheric height away from the camera is where haze should start, and max is at 5 times that distance, it's at its maximum. The sunset is controlled by an angle to the star from the planet's normal. This is documented here. All of these properties have this hover text. So if we lower haze start, we'll see haze impact faster, and if we raise it, it'll be later. And then if we change the max by lowering it, we'll have a less smooth transition. And if we raise it, we'll get a much softer transition. And then for sunset start, very similar. If we push it towards 1, the sunset is earlier, and if we reduce it, it comes later. And by bringing max up to meet sunset start, we get a less soft transition, more immediate. Alright, let's reset these values, and we'll move on to clouds. So let's go find a cloud. Actually, real fast, let me go ahead and increase the resolution so that we can see the clouds for what they would look like in-game, since it's set to quarter. And we'll mess with the cloud style. This is a better one. So color's pretty self-explanatory. It's the base color of the cloud. Light penetration controls how light is calculated through a cloud. These are the step sizes, so if we increase them, shadows will get stretched out and even fall onto lower clouds. And if we decrease it, the shadow will converge. Light scatter impacts how much light is approximated to bounce around inside a cloud. If we increase this value, the clouds will appear brighter with less shadows. And if we decrease it, we get more detail on the shadow. Beers and powder factor control the internal lighting calculations. Lowering beers will create shadows sooner, a darker interior of the cloud. And increasing this will lighten the cloud. And powder just handles those silver linings. Density factor handles the density of the cloud as it's measured from the textures, the noise textures. And then next we have animations. Let's find a group of clouds. This is good. So right now, animations are enabled. We can't see them, but if we do our trick, this is a very subtle animation. Pausable lets the animations be paused in-game if the scene tree is paused. Reverse reverses animation. We'll go ahead and increase this so that we can just see it. Maybe a bit more. There we go. So reversing does what you think it would do. And then the rates here handle the large, medium, and small noise. And then our mask, which is this cloud map here for this case, is controlled here. And then we have detail rate, which controls the individual details for the clouds themselves without moving them. And we'll go ahead and disable animations for the rest of this. So noise adjust handles how these various noise textures are actually combined. Increasing falloff will reduce the effect of the textures being added together, so we'll get less detailed clouds. And if we reduce that value, the noises have a greater impact. The threshold is the minimum and maximum, so if we reduce our min, we should get wider clouds. And increasing max will kind of thin them out. And bringing them very close together will make hard edge clouds. Okay. And then wisp factor handles these little wisps on the edges of clouds. So we can get very wispy clouds here. Or we can reduce that to just get soft clouds. Global scale impacts the total scale of the clouds. It moves everything uniformly. We'll look at that more later. And then we have individual scales for the various noise sizes. You'll see if we hover over there, it tells us which is which. So large, medium, small, and for the wisps. So if we increase our wisps again, we can then increase the scale and get different looking clouds. And then if we reduce that, we'll get very particulated clouds. And then, of course, changing the scale to our larger noise, we change the scale of the individual clouds. And then we have offset. So offset along X will be our west to east on a planet, and the Y will be our north to south on a planet. These offset control the positions of the clouds within the mask. And then we have the noises themselves. So height is relatively complicated. If we hover over, we'll see that the different channels mean different things. Before we go changing it, let's make it unique again. And recall there's a sub-resource here, so we'll want to right-click on that and make both unique. So let's change the position and the density of our top layer of clouds. We'll want to change these together. So our blue channel is our offset. So let me add 0.5 here. And I want to copy that value across to the ending point. This keeps the clouds intact. Essentially, we want the value applied across the entire layer. And we can change our density here. And since we have 2 points in here, we want to do it like that. So if we pull these apart too, we can increase the terminating line there, and then we pull the cloud out. And we can do the same for the other layer in the opposite direction. Now it is important to remember this height setting is exponential. So smaller adjustments down towards the bottom are actually more detailed. And the further out you go, the less distance you're actually covering. We'll go ahead and restore that. And then mask can be anything from a noise texture to something like this where it's painted. The painting here has limitations. Because of the way that I did it, the black can never be filled in. So if this was a gray, we could use the noise adjustment to fill in the lower bound threshold. But because it's black, we can never really quite reach that. And then feel free to play around with large, medium, and small noise. That's the combination that actually produces the individual clouds within the mask. And Wisp has a bait curl noise. There's no modifications you can do here. You could replace it with a different texture, but it should be some kind of curl-like noise. Let's go ahead and really shake up the Earth profile here. Remember, we did save this as our own profile, so it won't override Earth. I'm going to go ahead and replace this with an existing texture. Clear out those errors. Then we'll come over to the atmosphere, increase its height, and color, why not? Then we'll come back to clouds, and let's really fill it in. There we go. That's looking pretty different now. And if we want to go back to Earth, we can just load in the Earth one. And we can bounce back and forth as we want. Now to deal with flat worlds. So we're not working with a planet. Let's click over here and reload the template. Go ahead and reassign my light. Well, actually, let me make it unique, and then I'll reassign a light. We'll go ahead and enable flat world, and we'll load in a flat Earth profile. Let's move that sun direction. And now the clouds and the atmosphere extend to the horizon. Let's increase that resolution, just for the video. And you can see objects can intersect clouds. There is some artifacting that can happen at the edges. This is something that I'm currently working on. And now let's come back to scale. So let's get this 50-meter planet model encased in the atmosphere. So I'm going to open up my planet profile. And real fast, the position here, the Y component, dictates sea level. So if I raise that up, the floor will raise up as well. But I'll return it back to 0. So if I open up atmosphere height here, and then clouds, noise adjustment, and that global scale we looked at earlier, if I increase the height by a factor of 100, you'll see the clouds don't automatically scale to that. But we can get them to by increasing this by the same factor. So now we're in a much larger atmosphere. And we can reduce the atmosphere as well. So the total scale we could bring down to 5. And now we're back to a smaller scale. And everything else, other than the cloud's global scale and the height, will automatically adjust to these scale factors. So as long as you keep these paired together relative to each other, you should have the same effect just scaled up. And that's pretty much everything in terms of what you can configure under the profiles. Now let's look at setting this up from scratch. So I'm going to close this scene and create a new scene. And we'll add a world environment. Go ahead and create a new compositor. Expand the array and add an element. And instead of loading the template, I'll just create a new clouds LP here. You'll see it gives an error missing profile. So we'll need to create profiles to fill this in. Same thing with cloud quality profile. We'll just use an existing one. But we'll create a new profile here. And then you'll see next it says that it doesn't have any textures, so we'll want to fill those in. And we can just use the existing assets that come with the add-on. But of course you can use your own. Or create brand new ones here. Now that these are filled in, we're still not seeing anything. That's because the shader needs to reload. So we'll come up to reload, and we'll click it, and it will reload those textures. The final thing I want to talk about is script integration. So I'll go ahead and create a camera. And we'll place it somewhere. So let's add a script to the camera. We'll just make it built in. And we'll get the world environment. We'll do onReady. And CloudsLP gives us a static method we can call to help us get the effect. So get from node. We'll pull it from the environment and set it to a variable. We might want to access it later, so and we have access to everything here. So if we open up the profile and go to the atmosphere, S for style, and we can change the direct color. Change it back to purple, and we can also move the position. So we could move it to the camera's global position. And we'll want to attach our environment to the camera. And we'll go ahead and run. And now the atmosphere is positioned at the center of the camera, and we've changed the sky color. So we could, if we had a planet that was moving, we could have a script that updated the position, or anything else. And that's all there is to that. If you have any questions or issues, feel free to go to the GitHub and report issues here. And of course, the add-on comes with a scaled-down version of this Readme, just the guide really, and the features. But the Readme on GitHub is a bit more expansive. It also includes performance figures.